Hello students, in last lecture we have discussed about concept of motion. Also we have taken detail of what is called distance and what is called displacement, and we have calculated the normal problems related to distance and displacement. In today's lecture we are going to learn about types of motion. Also, we will learn about what is called speed, then what is called velocity. We can also plot a difference between the speed and velocity. So from that we will have a concept of scalar quantity and vector quantity, and we will solve some problems related to speed and velocity. Okay, so in types of motion, how many types of motions are there? So generally there will be two types of motion. One is uniform motion, and the another one, it will be non-uniform motion. So what will be there in uniform motion and what will be there in non-uniform motion? Also, why speed is called scalar quantity and why velocity is called vector quantity, that also we are going to study. Okay, in types of motion we will have two types of motion. First is uniform motion and the another is non-uniform motion. Now what is called uniform motion and what is called non-uniform motion? So let us try to understand. In uniform motion, the distance traveled by the object in every interval of time, it will be same. Okay, so here we can say that distance traveled by object at every equal interval of time is same. So if the distance traveled by the object is same in every equal interval of time, so that is considered as uniform motion. And in non-uniform motion we can say that distance traveled by an object, here we can write it like by an object at every equal interval of time is not same. So that is considered as non-uniform motion. Now let's take an example of uniform and non-uniform, so it will give us the clear concept. Suppose here we can write that, suppose this is our timeline, so 0, 1 second, 2 second, 3 second, 4 second and 5 second. See, here there is equal interval of time and that is 1 second. If there is one object, it travels 5 meter in first 1 second. If it is uniform motion, so in another 1 second it will travel 5 meter. In third interval it will also travel 5 meter. In fourth interval it will also travel 5 meter. In fifth interval also it is going to travel 5 meter. So here you can see that the distance traveled by the object is equal in every equal interval of time. So this type of motion is considered as uniform motion. And what happens in non-uniform motion? We will try to understand it with similar type of example. Suppose time axis 0, 1, 2, 3, 4 and 5 second, right? So here we are taking time axis t. Right? If here we can see that interval of time is same, but the distance traveled by the object is not equal in every interval of time, so that will be considered as non-uniform motion. Like suppose in first second object is traveling 5 meter, in another 1 second suppose it travels 3 meter distance, in another 1 second again it travels 5 meter, here it travels suppose 4 meter, here in another 1 second it travels 2 meter. So here you can see that every interval of time which is same, but the distance traveled in every interval of time it is not same. In first second it is traveling 5 meter, then in another 1 second it is traveling 3 meter, then in another 1 second again it travels 5 meter, here it travels 4 meter and then 2 meter. So this type of motion, it is not uniform motion. Here you can see that at every equal interval of time the distance traveled in first second, right, in the second interval of time, third interval, fourth interval and 5 interval, time is also same and distance traveled by the object is also same. So this is a uniform motion, and here at every equal interval of time distance traveled by the object is different, so that is considered as non-uniform motion. As we have seen what is uniform motion and what is non-uniform motion, now we will take the another concept, that is of speed and velocity. Now what is called speed and what is called velocity? You have heard this word many times, that speed. If we both are having a race, right? If the distance is 100 meter, I reach in 12 seconds and if you reach in 15 seconds, so what does it mean? It means that my speed is more in comparison to your speed. So what is the connection of speed? How we can identify the speed? What is relation of distance, speed and time which is taken by the object during its motion? So if we want to define speed, how we can define it? It is very simple. Definition of speed is also very simple. From the formula also we can define it very well. So what we will take as speed? It's very easy. For speed and for velocity also we will know different quantity, right? What is difference between speed and velocity, that also we are going to study. Now speed means what? If we write the formula, from that we will try to understand that speed is equal to distance divided by time. Okay, and here if we consider velocity, so velocity is equal to displacement divided by taken time. So how we can write this, or how we can define it? So simple, here we can say that what is speed? Speed means distance travel in unit time. Again, here whatever is there in denominator we can write it as a unit. So distance travel in unit time, that is called speed. So here we can write that distance traveled in unit time, that is called speed. Okay, from this what will be our unit distance? It can be measured in meter, and time it can be measured in second. So our unit, it can be meter and unit of time second. So meter per second. We can also write it like this: meter second inverse if the distance is in kilometer, right, and if the time is in hour, so we can write it like this, kilometer hour or kilometer hour inverse. Generally in the speedometer which we see in our vehicles, the unit is like this, kilometer per hour. If anyone say that object has traveled 50 kilometer per hour, it means that in 1 hour the object has traveled 50 kilometer of distance. So what is speed? It is distance covered in unit time or distance by time. So that will be considered as speed. Okay, here distance is also scalar quantity. It don't require any of direction, and time also don't require direction. So speed is our scalar quantity. Scalar quantity means which requires only magnitude. It don't require direction to mention. So speed is our scalar quantity. Okay, if we see towards this velocity, what is here difference? You can see that here it is distance by time, here it is displacement by time. Now what is displacement? We know that displacement, it can be 0 also, it can be positive also, and it can be negative also. So in displacement it is very necessary to write its magnitude and to write its direction. So displacement is vector quantity, so velocity will be also our vector quantity. So what is difference between scalar quantity and vector quantity? Scalar quantities, it requires only magnitude, while vector quantities, it requires magnitude and direction both. How we can define velocity? Here we have seen that distance traveled in unit time, that was speed. So here we can write like this, the displacement done in unit time, that will be considered as velocity. So displacement done in unit time, that is considered as velocity. How we can find its unit? Similar, here displacement, it can be in meter, and if time is in second, so its unit will be meter per second, or we can also write like this, meter second inverse. If the displacement, it is in kilometer, so displacement for that kilometer, and time, if it is in hour, so we can write like this, kilometer per hour, or it is also written like this, kilometer hour inverse, right? Remember again, speed will be always positive. Another point, speed is always positive, while velocity, it can be positive, it can be negative also, and if the displacement is 0, so in such case it can be 0 also. If the object is in motion, so definitely speed will be always positive, it is not going to be 0. But in velocity, it is dependent on displacement. If displacement is positive, velocity will be positive. If displacement is negative, velocity will be negative. And if displacement is 0, so our velocity will get 0. So this way you can also plot a difference between speed and velocity. Speed is scalar quantity, while velocity is vector quantity. Scalar quantity required only value, right? It don't require direction, while in velocity it is vector quantity, so it requires direction and value both, right? And here we are having the definitions and unit and some important notes about speed and velocity. As we have understood the concept of speed and velocity, right, now we will know that the speedometer, right, it always gives us speed, it never gives us velocity. Okay, let's clear our concept of speed and velocity by using different illustrations. Here we are having illustration 8.1. In that object, it is traveling 16 meter in 4 seconds. Okay, an object is traveling 16 meter distance in 4 seconds, and another 16 meter distance in 2 seconds. So what we have to find? We have to find out the average speed. So it's very simple. that to find average speed, first we will require a formula. What is now formula of average speed? It is simple. Total travel distance upon taken total time. So average speed is equal to total travel distance upon taken total time. Now, from this formula, what we can say, how we can calculate it? It's very simple. Now, total distance. Okay, again read the question. An object is traveling 16 meter in 4 seconds and the another 16 meter in 2 seconds. So, how much our object is traveling totally? So, in first 4 seconds it is traveling 16 meter and in another 2 seconds also it is traveling 16 meter. So, the total distance traveled by our object, that will be 16 meter, this first one, plus 16 meter. And how much time it is taking? For this first 16 meter, it is taking 4 seconds, right? And for the another 16 meter, it is taking 2 seconds. So it is very simple. Total distance traveled, it is 16 meter plus this 16 meter upon taken total time. So for first 16 meter, it is taking 4 seconds, and for another 16 meter, it is going to take 2 seconds. So our answer, 16 plus 16, it will be 32, divided by 4 plus 2, that will be our 6. So as you all are brilliant, you all are genius, so 32 divided by 5. So our answer will be 5.33. Okay, 5.33. But it is very necessary to write the unit in every answer. Here the total distance traveled. So distance, right? In which unit distance is? It is in meter. So our unit will be meter. And time taken, it is in second. So our unit will be unit of distance upon unit of time. So unit of distance in sum, it is in meter, and unit of time, it is in second. So this way we will get our answer 5.33 meter per second. So the average speed of object, that will be 5.33 meter per second. Okay, here we have the second illustration, illustration number 8.2. In that, the odometer of a car, it reads 2000 kilometer at the start of a trip. So we are starting a trip. So before the trip is started, the reading of odometer, it is 2000 kilometer and 2400 kilometer at the end of the trip. So at starting it was 2000 kilometer, at end of the trip it is 2400 kilometer. Means now it's very simple that how much distance we have traveled. So that will be our final position minus our initial position. Means it will be 2400 minus 2000. We will get 400 kilometer. And how much time it is taking? It is taking 8 hours. We have to calculate that in kilometer per hour. Average speed we have to calculate in kilometer per hour and also in meter per second. Now we have different ways. Here the units are in kilometer per hour. So we will directly get the answer in kilometer per hour. And then we can convert that kilometer per hour into meter per second. Okay, let's see how. First of all, let's find out the distance, how much distance we have traveled. So, distance traveled is equal to, it is simple, at the end of the trip we are getting 2400 kilometer and at beginning it was 2000 kilometer. So, we will get 2400 minus 2000. So, we will have 400 kilometer, which is the distance traveled by the car. How much time it takes? So time. How much is the time? The time is 8 hours. So the time will be 8 hours. So simple. Now let's find average speed. What will be formula of average speed? We can write it like this, that speed, and for average we will write it like this, is equal to total distance traveled by an object upon total time. This will be our formula. According to formula, that what is total distance? It is 400 kilometers. So we will get 400 kilometer divided by how much time it is taking? 8 hours. So 8 hours. As we do the calculation, we will get that 400 divided by 8, right? So our answer will be 50, right? So our speed, it is average speed, we will get 50, but the unit will be, this is in kilometer and this is 8 in hour. So our unit will be 50 kilometer per hour. This is our first, what we have to find, the average speed. Okay, now second thing which we have to find, that this speed in meter per second. We have different ways. If here we convert this kilometer per second, sorry, this kilometer into meter, right? How we can do that? 400 kilometer. Kilo means 1000. If we multiply 400 with 1000, so that answer will be of hour in meter, and this hour in second we have to convert, okay? Or directly we can do here. We will take out the shortcut. Here, let's try to do that. Keep this 50 as it is. We want here meter. So, kilometer, how we can convert it into meter? We know that 1 kilometer is equal to 1000 meter. So, instead of kilometer, what we can write? 1000 meter. So, into, we will have here 1000 meter. By hour, how we can convert hour into what we want? Second, right? So 1 hour is equal to how much seconds? Let's calculate. We know that 60 seconds means 1 minute, okay, and 60 minutes means 1 hour. So 1 hour is equal to 60 minutes, okay, and 1 minute is equal to 60 seconds. So if we want to convert 1 hour into second, how we can convert? 1 hour is equal to 60 minutes, and each minute contains 60 seconds. So 60 into 60, we will get 3600 seconds. So 50 as it is. Kilometer, instead of kilometer, what we can write? 1000 meter. So I have written here into 1000 meter upon hour. So instead of 1 hour, what we can write? Can write that it is 3600 seconds. So we can do like this, 3600 seconds. So here you can see our unit, it comes in meter per second. So as we will do the calculation, what answer we are going to get? Okay, as we will do this thing, as we will do this calculation, we will get the answer 13.9 meter per second. So simple. Here we are getting the answer 50 kilometer per hour, but we have to also find it in meter per second. So how we can do kilometer? It is 1000 meter, and hour, it is 1 hour is equal to 3600 seconds. So 3600 seconds. So here we get the unit meter per second. Okay, and by this calculation we will get 13.9 meter per second. If we don't want to do like this, we can also find that this kilometer, first we can convert this 400 kilometer into meter, and this 8 hours into second, and then we have to apply the same formula. So by that same formula, we will get the answer in meter per second. So I hope that you understood both of the illustration and you are clear about the concept of speed and velocity, what is called uniform motion and what is called non-uniform motion. Thank you.